Have you ever imagined seeing a saber-toothed tiger roaming the forest, or a dinosaur roaring in a park? This idea, once confined to science fiction, is becoming increasingly plausible thanks to advances in biotechnology. De-extinction, a term used to describe the process of bringing extinct species back to life, is a scientific field that has captivated and sparked debates worldwide. But what exactly is de-extinction? Is it like the movies from Jurassic Park? In simple terms, it is the attempt to reconstruct an extinct organism from its genetic material. This material, usually DNA, can be found in well-preserved fossils, samples preserved in amber, or even tissues of recently extinct animals. Once the DNA is sequenced, scientists can compare it with that of closely related living species and, through techniques like cloning and genetic editing, attempt to create an organism genetically identical to the original. The saber-toothed tiger, a giant frozen in time. Discovered in the frozen depths of Russia, a 32,000-year-old saber-toothed tiger cub astonished the scientific community. Preserved almost entirely intact by permafrost, this discovery offers a glimpse into a distant past and fuels hopes that one day we might bring these magnificent creatures back to life. With sharp fangs and a muscular build, the saber-toothed tiger was an apex predator during the Ice Age. Its extinction, around 10,000 years ago, remains a mystery, but climate changes and competition with other animals are believed to be key factors. The discovery of this cub presents a unique opportunity to study saber-toothed tiger DNA and potentially to clone an individual in the future. However, the path to de-extinction is fraught with challenges. DNA integrity, the need for a surrogate mother, and ethical implications are just a few of the hurdles to overcome. Mammoths, engineers of the future. Mammoths, with their imposing ivory tusks and thick fur, were true giants of the Ice Age. Though extinct for thousands of years, scientific interest in these creatures continues to grow. Currently, several ambitious projects aim to bring mammoths back to life, hoping to restore ecosystems and combat climate change. The idea of resurrecting mammoths is not merely fantasy. Unlike what many may think, scientists are diligently working on genetic editing techniques to modify Asian elephants, close relatives of mammoths, and introduce genes that provided mammoths with cold-adapted traits, such as dense fur and a thick layer of subcutaneous fat. The goal is to create a mammoth-elephant hybrid capable of surviving in Siberian tundras, which is arguably the closest to de-extinction we are today. Why such interest in reviving an extinct species? Mammoths played a crucial role in maintaining the tundra. By uprooting trees and shrubs, they made space for grasslands to grow, which reflected more sunlight and helped keep the soil frozen. With the disappearance of mammoths, the tundra began transforming into forests, accelerating permafrost, melting and releasing large amounts of methane, a potent greenhouse gas. The hope is that reintroducing mammoths to the tundra could reverse this process and help combat climate change. Additionally, mammoth research could lead to breakthroughs in regenerative medicine and the conservation of endangered species. However, the de-extinction of mammoths raises numerous ethical and practical questions. What impact would these animals have on today's ecosystems? Is it ethical to create animals for experimental purposes? And how could we ensure their welfare in a world vastly different from their ancestral environment? The Dodo, a story of extinction and hope. The dodo, a chubby and clumsy flightless bird, became a symbol of extinction. Endemic to Mauritius, the dodo's inability to fly, docile nature, and the taste of its meat made it easy prey for sailors arriving on the island in the 17th century. Within less than a century, the dodo was wiped out, falling victim to hunting, habitat destruction, and the introduction of invasive species. Despite its tragic history, the dodo has become a target of de-extinction projects. The simplicity of its genome compared to other birds and its relatively recent extinction increase the chances of success. Scientists are recovering dodo DNA from preserved museum samples and seeking close relatives to serve as hosts for cloned embryos. Bringing back the dodo is not just an exercise in resilience. By resurrecting this bird, researchers hope to learn more about the processes of evolution and extinction while contributing to the conservation of other endangered species. Furthermore, reintroducing the dodo to its original habitat could help restore ecosystems, much like the mammoth. Dinosaurs, a distant dream? The image of a Jurassic Park filled with roaring dinosaurs has fascinated humanity for decades. However, the reality of de-extincting dinosaurs is far more complex than portrayed in films. The primary difficulty lies in the quality and quantity of available DNA. Over millions of years, DNA degrades, making it extremely challenging to find complete and usable genetic sequences. Additionally, even if viable dinosaur DNA were found, no living species is closely related enough to act as a surrogate host for embryo development. Instead, scientists have explored the idea of genetically engineering modern birds, such as chickens, to express traits of their dinosaur ancestors. This technique, known as reverse evolution, involves activating dormant genes in bird genomes that encode characteristics like teeth, claws, and long tails. Although promising, much remains to be discovered about dinosaur embryonic development. Giant sloth. Much larger than modern sloths, the megatherium could reach up to 6 meters, 20 feet, in length and weigh up to 4 tons. With sharp claws and incredible strength, these creatures fed on leaves and tree branches. The giant sloth lived in South America during the Pleistocene epoch and coexisted with early humans, who even hunted them. Titanoboa. This super snake, which lived around 58 million years ago, was the largest serpent to have ever existed, measuring over 13 meters, 43 feet, in length, and weighing an estimated 1 ton. The Titanoboa was the apex predator in its environment. Its fossils were found in Colombia, indicating that it inhabited regions of humid tropical forests. The de-extinction of these giants. The idea of bringing back to life creatures like the giant sloth, Titanoboa, and Megalodon is tempting, but it faces even greater challenges than the de-extinction of more recent animals. Megalodon, the largest shark to ever swim the oceans. The Megalodon could reach up to 20 meters, 65 feet, in length, and had teeth measuring over 17 centimeters, 6.7 inches. This prehistoric creature fed on large marine mammals, such as whales and seals. Although its fossils are rare, the presence of megalodon teeth in various parts of the world indicates that this species was widely distributed across the oceans. The return of the megalodon to the marine ecosystem would be a catastrophic event with unpredictable consequences. As the largest marine predator of all time, the megalodon would quickly occupy the top of the food chain, causing significant ecological imbalance. The megalodon would prey on large marine mammals like whales and seals, driving many species to the brink of extinction or complete eradication. Consequently, a drastic reduction in the populations of megalodon's prey would trigger a cascading effect throughout the ecosystem, impacting everything from small fish to seabirds. The reintroduction of these giant creatures into modern ecosystems could have unpredictable consequences. For example, the giant sloth could alter local vegetation and fauna, while the Megalodon could disrupt marine food chains, as its sheer size would naturally require much more food. In summary, the de-extinction of giants like the giant sloth, Titanoboa, and Megalodon is a scientific and ethical challenge that remains far from being achieved. Reviving extinct species raises profound ethical questions. How can we ensure that revived animals lead dignified lives, free from suffering? How would these species interact with today's ecosystems? Should we focus on saving currently endangered species instead of bringing back extinct ones? While de-extinction offers hope for restoring lost ecosystems and deepening our understanding of evolution, it must be pursued responsibly, prioritizing the well-being of animals and environmental health. Ultimately, de-extinction invites us to reflect on humanity's role in the natural world and our responsibility to future generations. It challenges us to find a balance between scientific progress and the preservation of life on Earth. Imagine what the future holds. Extinct creatures walking among us, and science breaking the boundaries of what's possible. If this fascinates you as much as it fascinates us, don't miss out. Subscribe now to our channel and turn on notifications so you'll be the first to dive into the mysteries of science, history, and the incredible innovations shaping our world. And trust me, you won't want to miss the next video. See you there.